Up next, we have Mike Amundsen. Hey, Mike.
Hey, how you doing? Good to see you, Jen. Happy to
Good
join.
to see you. Thank you. And for those of you listening, Mike is an author, speaker, advisor to Amundsen.com. So thank you, Mike.
You bet. So we all set? Here we go. Let's get right to it, Jen. So we're going to talk about designing and building great APIs. And I'm actually really excited to be here to talk to you about this. But I just want to say first, as Jen mentioned, this is me. This is how you find me on LinkedIn and GitHub and Twitter and YouTube. I'd love to connect. I'd love to learn about what's challenging for you in this web API space. Most of the material that I present is something I learned from someone else, and I want to learn from you. So please feel free to connect with me anytime. Now, most of the material that's coming out of this talk is from a book I wrote for Pragmatic Publishers called Design and Build Great Web APIs. I might rush through some of the material here because I want to give you the kind of the big picture, the big life cycle picture that we've been talking about. But don't worry, I'll share these slides at the end. You'll be able to get these slides. And if you're really interested, you can dig in more in the book. So I want to talk about a handful of things. I want to talk about this notion of foundations of designing and building APIs. And we're not just building them, right? We're designing them too. We're going to talk about design and build. We're talking about release, which is its own business. And then I want to talk about the most important part, which is modifying your API. API's lifecycle, the longest part of that lifecycle is usually up and running in production, but that doesn't mean it doesn't change or it doesn't improve or you don't need to give it attention. So the modification part of the life cycle is really, really important. But let's start with foundations, sort of the basics. And I really only want to talk about two key elements right here. And that is this notion of API first, which you've probably heard before, and a little bit of talk about the difference between HTTP, the protocol, web, the practice, and REST, the theory or the concept. So in API first, what we're really trying to do here is we're trying to solve business problems. That's the only reason an API needs to exist, to solve a problem. And that problem needs to be solving, the problem it needs to be solving is the problem other people have, right? It's other people's problems, not yours. I don't have a problem releasing my database. I have a problem with people using that database, or my users have a problem finding the data they're looking for. So I want to design with people in mind. And that means I want to think from the design aspect first. And that means business problem plus target audience equals the API design that I give. When I'm designing, whoops, I'm sorry about that. I just went to the very end. I apologize here. Why, that's terrible. I've never done that before. It's the first time for everything. So this notion of design, if I'm designing it for someone who is got a college degree in computing, I'll design it differently than somebody who's working in marketing or finance or sales who are just trying to solve a problem right away. Design matters. Now, this idea of HTTP in the web and REST is talked about in various different ways. It's when you combine all of those things that you can build an API. HTTP is just a protocol. There's stuff about methods and URLs and message bodies. That's all technical stuff that nobody designs. That was created 30 years ago. Web is a practice, so there's the separation of concerns between the script and the design CSS style and the actual markup itself. There's links and there's forms to get things done. That's a common practice that we can adopt when we create our designs. REST is a style of design. REST separates the properties of the system and the requirements you need and builds in constraints to make sure that we all build them in similar ways. So you'll take each of these in a slightly different manner. Everybody starts with the same protocol. Most people adopt the common practices of the web, and some people use this REST dissertation that's now 20 years old in order to decide how they design their APIs. But it's not the only way to design APIs. GraphQL, gRPC, there are lots of ways that you can do this besides REST. So keeping those in mind, I've got this Venn diagram that tells me where my API lives, and I've got solving problems as a key to the story. So let's talk about design work. Design work is very important. I would actually say it's the most important. It's the hardest to teach. It's the hardest to get consistent about, and it's the where you gather the most information about the customer. So it's really, really challenging. So I talk about designing APIs in 3 steps: creating the model, designing the API that matches that model, and then describing it in a machine readable way that other people can use. So when you're thinking about modeling an API, what you're really doing is modeling how people interact in the universe. You may be modeling the onboarding of a customer or the checkout of a shopping cart. You may be modeling writing a blog, but there are interactions involved. And there's this thing called Norman's life cycle, which talks about how you can model the world. There's a goal in mind. People have a plan, they specify, they perform an action, and then they see if that action really solved their problem. Think about turning on a light. I need to turn on a light to read. So I got to plan and specify. I got to go find the switch. I flip on the switch. That changes the world. And I see, is it now bright enough? Well, it turns out that switch just turned on the air conditioning fan. It didn't turn on the lights at all. So I interpret it as saying not meeting my goal, and I do this again. That's a cycle. And everybody operates in cycles, whether you're driving to work, writing a blog, onboarding a customer, or just trying to read a book. So designing your APIs as cycle is a huge advantage. You don't design as a straight line. You design as this cycle, as this constant loop. And you can write an API story that talks about the details of that cycle. Here's an API story that says we want to keep track of companies for Bigco Incorporated. Here are the data we use, the actions we use, and the processing we're going to do. Notice there are no lines here. This is just a collection of story information. Now you can use user stories or API stories. Job stories is another one that's used oftenly, but we want to document this in simple narrative terms. I don't need to be a rocket scientist to understand your story. Now I have to turn that story into a design. I have to start thinking in a designer's kind of way. I need to ask questions, figure out how things are connected. I need to solve the jobs to be done, to use the Clayton Christensen term. I need to figure out what is it we're trying to do here. And then I need to write some diagrams. So I'll take that description, I'll create a diagram, I'll come up with some maybe definition files or documentation. All of this is in a cycling process of getting more and more specific to figure out what that design is going to be. And that design eventually needs to be described in some kind of way. So I typically describe this in a diagram. Notice these are the activities. I need to get a list of the companies. I need to filter the company list. I want to read a particular record. I want to update a record. I want to delete a record. I want to create a new record. And notice, by the way, these are all things that are in loops. I get a list, and I go back to home. I search, and I get the collection. I get the item, and I can go back to the collection. Again, we're talking about that loop, which is so very, very important. And again, this is not too technical. Almost everyone can figure out what's going on in this diagram. And that's really important too, because you can communicate with stakeholders, your target audience, whoever that is, to make sure that you're actually covering the actions that are important. Now, eventually you need to turn that diagram into some kind of document. And there are lots of formats: OpenAPI, GraphQL's schema definition language, async API, protobuf, WSDL for SOAP. There are all sorts of definition files, but often you need a kind of a general design file to start with. Leonard Richardson and Mark Foster and a few of us got together, and we created this thing called the application level profile semantics, or an ALPS description, which is sort of a high level description of all of those actions that kind of turns this diagram into a document. And it just describes each individual activity and lets the details of implementation happen later. You can then take this diagram and actually use it to implement a gRPC API or a GraphQL API or anything else. I won't go into the format now. You can read more about it in the book and online. You can find alps.io. You can find more. But what you want to do is make sure you have a machine readable description. That's really the key to getting a good design. All three of these things, your story, your diagram, and your description, need to be checked into the repo, need to be checked into source control, because this is your history. And in fact, when I work with a team, every iteration of our diagram, every iteration of our story gets checked in as well. So now we've got a decent design, and we've got a design that's described in a machine readable way. Now it's time to do some building. Now I'm going to describe a building system that I use, a framework that I use, because it matches very much this idea of this model diagram system. But you may have your own. It's not really important exactly what framework you use. What's important is the cycle. And I actually go through, again, 3 steps: sketching, prototyping, and building. What's a sketch? Sketching was first introduced to me by Ronnie Mitra of API Academy, and he talked about how the physical architect, Frank Gehry, draws pictures about the buildings he's going to create. Here's some entrances to buildings. One is a very breezy one. One is a kind of a severe, narrow entryway. Another one is a kind of a palatial, kind of almost castle entryway. Design matters. I use apiary blueprints to sketch out things really simply, not the whole API, just a few individual steps. I write up an API profile using Blueprint because it's markdown and I can get it within seconds. Write some markdown, press F5, I can see if that's really the inputs and the outputs that I really want. I don't want to spend a lot of time because the way I work in this sketching space, sketches are meant to be tossed, they're thrown away, they're just ideas. And I do these in kind of brainstorm sessions with teams. That's very different from prototyping. You can think of the garment industry as well. What if I need to create a special outfit for like an IPO, right? A gown, a dress, a suit, whatever I want to do. In the garment industry, you might be working with very expensive cloth, but you're not going to do the first version of the garment in cloth. You're going to do it in cheap canvas, what's called toile or muslin, right? So we're going to use this same idea in APIs. We're going to prototype using something like OpenAPI or something like that, where I don't have to write a lot of code, but I get a lot of specificity and I can test it. I get all the endpoints, all the arguments, all the headers, everything I need without having to write code. And that lets me explore all the details of the designs I've been working on. Prototypes are made to be tested. Think about prototyping a vehicle or something like that. It's a complicated process, but I need the details before I go to production. So I use OpenAPI for my prototypes because I can get very detailed and I can test them very well. Finally, I need a repeatable process for building. Building is not too much of a big deal. I can convert that prototype and design into code. Now, I use a system that uses this multi-step process. I record the data I need, the actions I need, the resources, how I represent them on the line, and all of the transitions back and forth. I'm not going to go through this here. You can take a look at this online if you want to. But actually, what I do is I actually write code in a way that allows me to decide later things like whether it's going to be JSON or XML or HAL or Siren or Uber or Mason. All of these kinds of things I can decide later. I create all the endpoints that come from my diagrams, and then I figure out exactly what format each one is going to be represented as. And then I can go ahead and write all of the transitions, all of the steps, all of the functionality, create and filter and read and write, and attach them to outside examples. So sketching, prototyping, and building. And like all the other things we talked about, it's a cycle. It's a sort of a kind of agile kind of loop that I can work over and over again. So we've gotten pretty far. We've got this idea of what our real target is. We talked about the design. We've talked about the build. Let's talk about releasing. Now, like everything else, releasing is more than a couple of things. I've saved testing and security discussions until this segment. In reality, you're going to be testing all the time, but you know, in a talk, I gotta do something here. So test, secure, and deploy is really important. So from the testing space, you need to test your interface and not your code. Now, you may need to test code if you're writing the code, but often if you're just creating the interface, the API, you need to test that interface and make sure that it follows all of the promises, that if you give it these arguments, it's going to return back these elements. How it does that is another story. You also need to test both the happy and the sad path. I need to test things that would return 200. I also need to make sure I know what's going to return 400. So invalid arguments, duplicate records, all sorts of other things need to be tested as well, and make sure that I can confirm the interface does that as well. Now, I use a thing called simple request testing, which is basically just curl. I actually have a little tool that makes it easy to do. But for serious testing, for repeatable testing for builds, I use Postman, and I automate Postman with Newman. And I use a kind of a behavior-driven design process for testing. Whatever you do, you need to make sure you test the interface, always use happy and sad path, and make sure you have a scriptable test in the process. So this is me with Newman and Postman, and I write some libraries. I cover them in the book. It's not too important here. Now in security, I kind of boil this down to a couple of key elements that you're going to have to cover in your life cycle. Encryption, identity, and access control. Encrypting the message is usually taken care of by HTTPS. You don't need too much fancier than that. In some special cases, you may need to encrypt certain fields. You need identity. I need to know who you are, but you need to separate identity and access control into two separate parts. What you can do is different than who you are. So access control is, can I do a get? Can I do a put? Can I do a post? Can I do a delete on a particular URL? Identity is who I am. I'm Mike. I represent a manager, so on and so forth. I typically use machine-to-machine authorization with JOT tokens. So I use Open API, OpenID, and I use Auth0 as a provider in the book. You can use lots of different providers. I think this is really the best, the best way to go, but it's entirely up to you. Your organization maybe use something different, but you need to make sure you've got all that security, and that security becomes part of testing as well. Now we'll talk about. So here's an example. The thing is with OAuth that I wanted to talk about here is it's a pretty complex series of steps. Unless you're really good at this, and unless it's really your core business, I don't suggest writing your own processing for handling authentication. Get a library that you can count on, that's vetted and trusted by your organization, and use that library consistently across the organization. There are too many possible things to go wrong, too many mistakes that can come up, too many zero-day bugs that arrive every once in a while for you to have to maintain all of your own authorization and authentication code yourself. Now, deployment comes in a couple of different flavors. You can do coding, check-in, testing, staging, and production, but there are lots of other things about continuous integration, continuous delivery, and continuous deployment. Continuous integration means I check in every time I check in some code, I build it to make sure it's still working, and I run the tests. If it's not working, I back it out. Continuous delivery is every time I build it and test it and it succeeds, I put it onto a staging server where other people can start to deal with it. Continuous deployment is where I put it not just on the staging server where it gets tested, but it automatically gets deployed into production as well. That's a pretty long leap. Not a lot of organizations can go all the way to automated deployment, but you can definitely do that if you can make that a goal. Automation improves safety. That's one of the reasons to write scripts for pipelines for deployment. It's because you do the same way over and over again, and that gives you a chance of doing it correct over and over again. Now, I actually, in the book, I talk about using Heroku and Git to do a push. So that becomes my pipeline. You may have much more involved pipelines in your organization, but this allows me to make sure that everything gets recorded, everything gets automated, and everything can be repeated over and over again, including Heroku does a great job of backing out a broken deployment. If the deployment doesn't test properly, it will actually revert to the previous production element, which is what I want. So testing the interface and behavior using Postman and Newman. Security using client credentials and JOTs, and I use Auth0, but whatever OAuth provider you want to look for. Automating deployment as much as you can, and in my case, my pipeline is Heroku Git push, but you may have some other ones as well. So we've gone a long way. So we've designed it, we've built it, it's now in production. Our job has just started. Because the most important part is what happens next, modifying it over time. So modifying your API happens all the time, fixing bugs, adding features, bringing on more users. There's always a chance to improve it. And you need to have a strategy as part of modifying as part of your life cycle. So I want to talk about a handful of those. First of all, you have to have some principles on modification. First, do no harm, the Hippocratic Oath of APIs. Make sure you don't break any client that already exists. No breaking changes. We've been doing it with HTTP, we've been doing it with HTML, we've been doing it with TCP/IP for 40 years. You can do it on your API too. No breaking changes. If you have to break, fork. We call those forks versions, but that's a separate version, and they're not going to be merged back. That's version 1, that's version 2, that's version C, whatever you want to call it. That's a fork, and those are separate. Salesforce, for example, I think currently is on fork number 50, right? Everybody has their own strategy for solving that problem. And the other one is knowing when to say no. You know what? I could add another feature, but it's just going to disrupt the system. I'm going to have to spend money on testing and so on and so forth. It's not really going to improve the situation enough. I'll start a new API, a new fork, if I want to add that feature rather than disrupt the one that I have. Now, when you're designing, there are a few things that you can do to make sure that you don't break. And those are the 3 rules. You can't take anything away. I can't take away a URL or an argument or stop passing a property back. I can't redefine the meaning of something. I can't say the third argument used to be the count of pages. Now it's the count of users. Can't do that. And anything I add has to be optional. I can't add a new required input because that's a breaking change. So take nothing away, don't redefine, additions are optional. That's a great way to start. Now, how do you confirm that your changes are non-breaking? Use all the existing tests. Don't rewrite the tests. Use the same test you were using for release number 1. Add new tests for the things that you added that are new, but you have to use all the old tests. That's the best way to come as close as you can to making sure you're not breaking an existing client. And then it's time to do a release. And you have to be able to reverse your releases. The most important thing is to back out a release if it's not working. Don't jump off a cliff. Don't throw a new release at everybody and hope it works. Make sure that you can back it out. Have a parachute with you. Side-by-side releases is the definite strategy. Release version 1 and 2 at the same time. Let people move from 1 to 2 when they're ready, not when you're ready, so they can do what they need to do. It's possible to overwrite a release. As long as you're confident you're not breaking anything, you can overwrite a release. This is what HTML and HTTP and TCP/IP do, but they take years to do releases. And sometimes we only have months, possibly weeks, or even days to do a bug fix release. So overwriting can be tricky. Now, eventually you're going to need to shut things down. You're going to need to say you give up, that it's time to end this process. So you can put code in a public domain. You can do open source work. You can offer recoverable data and mark the thing as 410 gone. And that's what you need to do. All right. So do no harm, no breaking changes, use the tests, favor side-by-side releases, and have responsible shutdowns. That's really the whole story that we've talked about here. Foundations, design, building, releasing, and modifying. That's the cycle. And one more thing. Design is how it works. Not just how it looks, but how it works. You're creating things that are going to help solve people's problems. That's how you design and build great web APIs.
Thank you, Mike. And it looks like we have time for one question. And I think one of the biggest ones that a lot of people would be curious about is looking into the future. With the API landscape changing so much and incredibly quickly, what should we be looking into right now? And what should we be looking into in the future?
Here are the things that I see most people asking me about. First of all, they're asking about migrating existing services. So creating APIs that take into account the fact that you might change a service behind it, keeping those APIs, services separate and loosely connected is going to be really key. That's going to be a skill that we all need to learn. Too many of us just create a service and use that service's functionality as the API. The second one is linking APIs together, doing transactions, workflow, orchestration. All these kinds of things are going to be super, super important. That's when you get reusability. That's when you get the chance to actually take advantage of existing APIs in a new and interesting way. We're just starting to get on the verge of figuring out how we can create API workflows. So I think if you can get ahead of the game on that space in particular, talk about doing things like orchestration and documenting API lifecycle and landscape, that's going to be a huge advantage as well. So separating the service interfaces so you can migrate in the background, linking services together in some kind of orchestration. Those are, I think, the 2 big challenges ahead.
Thank you for that. And thank you for giving us some actionable items that we can use going forward. And thank you for joining Interface today, Mike. Talk to you soon.
Good to see you. Bye-bye.